I've got a series of slides here. I'm going to try not to use that too much, and so I'm going to just eliminate that screen right there so that we don't have that background image getting in our way. So first what I want to do is make sure that the calculator is set up to go, make sure everything is, all my modes are set back to the beginning. Currently at the status bar it says, well, I'm in complex mode and I got some other things going on, so I want to set this back to the very beginning. So I'm going to press Shift. I've got a clear above the number 9, and it's kind of a grayish color or a brownish color. So if I press Shift number 9, it's going to give me my options for how I can clear. I can clear the setup, clear the internal memory, or what I'm going to do is I'm going to clear it all. So I'm going to press 3. It's all menu driven, and it says press equals for yes and AC to cancel. I'm going to press equals, and now it says everything's been reset, so I'll press AC. My emulator, you see two screens. You've got the calculator screen, the emulator going. I've also got the calculator screen in large and my key fonts, my key log underneath. From time to time I will clear the key log just so that it just doesn't clutter up. But if you get lost, the key log will have a series of keys on there, and it'll keep going as long as I'm presenting. So first off, my status bar here says I'm in math mode. If I want to change the mode, the way you do that is you press the mode button, which is one of these buttons right up here at the very top. It also says setup, but setup is a brownish greenish color. So I'll press mode. I want to make sure I'm in mode 1. Well, let me see what else we have. We have distributions for statistics, verify, which is a very nice menu. We can do inequalities, vectors. Yeah, this calculator does do vectors and it does a very nice job with them. It does tables, matrices, equations, base N, statistics, complex numbers, and just computational. So I'm just going to go into mode 1. That gets me back into mode 1, so that means I'm ready to go. The other thing that I want to show you is the setup real quick. If I press Shift Setup, this tells you all the other sets that the calculator is currently set up in. It's currently set up in math, which means it's a natural display versus a linear display. It's degrees or radians, gradient. You can fix the number of decimals. You can go scientific, normal. If I scroll down, improper fractions is 2. This is mixed numbers, complex. You can go in statistics mode, table, you name it, you can change it. 8 has a few others. You can lighten and darken the contrast. So those are just some of the functionality keys to get you started, let you know where you're at, where you're going. So if at any point your answer doesn't look like it's something that you expect, that would be the place to go. So let's get started with something that I think is really great about this calculator. We've got templates, which is in our natural display. We'll show you mathematics the way it appears in your textbook. So here's a fraction. Looks just like a fraction. So you can just fill in the template. We got 1. I'll toggle over. Or I could have toggled down to 1 over 13. And you press equals, which operates similar to execute in some of our other calculators. But the equals menu will just spits the answer right back out. Now what's really nice is I've got this S to D key. So that'll let me change what I'm looking at, so what my current display is. I press S to D. It gives me the repeating decimal, including the bar. If I press it again, this is the non-repeating decimal, but it's fixed to 12 decimal places. If I press it one more time, I go right back to the beginning. So it does repeating decimals. Now the repeating decimals are really nice, because I like teaching math as not just, you know, here it is, this is the rule, this is what you've got to do. I like to use the calculator to help students discover rules and discover what it is they're learning. So it is a discovery tool, a lot more than it is simply a calculating tool. So I've got a repeating decimal key, which is this little red key, which is a square with a bar over the top. So I want to teach the students and see if they can come up with a rule for repeating decimals. So I'll start out with 0. We'll go like 1, 2. Well, let me put in my template. 0 point template. alpha square root. Now you see the template fills in the bar over the top here. I'm going to type in 1 and 2. Notice that the bar starts to expand. John, is that also a vinculum? That I don't know. But there it is. It spits out my fraction approximation.
Sorry, I was muted. Yes, that is correct.
That is a vinculum. All right, there's another use for that word. Vinculum is the bar over the square root. It is also the bar over the, or between the fraction. It is the bar over the square root. It is also in my repeating decimal, so you see the word vinculum. All right, so let's try another one. That first one, the students are kind of like, okay, I don't really see anything going on. So let's get into something like point, repeating decimal, 1, 2, 3. All right, that doesn't help them much. How about let's go with a prime number, point, repeating decimal, 11. 1 over 9. Let's expand that. Let's go with shift. Well, let me clear that one out. Point, repeating decimal, 1, 3. 13 over 99. So the last one was 11 or 1 over 9. Now it's 13 over 99. So let's see if we can develop a pattern. Let's try another prime number. Let's try 17. Repeating, 17 over 99. Let's try another one. 23, so we'll go with repeating decimal, 23. 23 over 99. So you start developing the idea of what is happening when you get a repeating decimal and how can I make a repeating decimal. So if I ask a student, can you make a repeating decimal like 123 repeating? Hopefully students will be able to come up with a pattern, 123. If I want those to repeat, I'm going to go over 1, 2, 3, 4. Again, we'll use the S to D key. They were close. I went one too many decimal places, but if I go back up, I'll go back, I'll change and delete. You notice all I did there was press the replay, which is the back arrow. It also replays by going forward, so that I can change my last input. Press the SD key again. There's my repeating 1, 2, 3. It's another opportunity to show you that this black arrow at the very top here means I've got more things that I can scroll through. So I can scroll through a lot of those things I did earlier. So if you did something at the very beginning of the show, we did 1 over 13, and the arrow now is showing I can only go down, so that means I can go down. I can either go down or up because that means I've got some before and some after. So I just keep scrolling until I get to the very end. And then if you wanted to change it, you can press the replay button or the replay the other way to go to the beginning or the end. Press back again and you can start toggling through. Let me clear out my history here. So now you develop the idea of repeating decimals. How can you make a repeating decimal of any sort? So you want to make any sort of repeating decimal. I want to make a repeating decimal with 59. SD, 59 repeating. So you start developing this idea of where does this come from? Instead of just giving them the rule or saying this is what it is, that's the way it's always going to be, it's a nice way of handing them over control of the class and seeing if they can develop patterns. Because the whole idea is we're trying to get students ready for that algebra class, for that advanced math class where it's all about the study of patterns, so we might as well get them started. But this calculator lets you do some things that I haven't seen in scientific calculators before. I'm going to start mixing some ideas. Let's mix a fraction with something abstract like pi. Pi is right above the times 10 to the key. It's right there in the greenish brown, so press shift. I get the pi symbol. Again, my answer comes right back to me the way I typed it in. Source to decimal, that's what the S stands for. It's S to D is source to decimal. Gives me a decimal approximation. Press it again. And there I am, right back. It won't do that every single time, but it does come pretty close. This is a non-CAS calculator, which means it does not have a computer algebra system, but it will let you do some things that more advanced calculators would do, like the square root 1 over the square root of 2. 1 over the square root of 2, which in certain math classes is not allowed. Statistics, it's perfectly okay. Calculus, I've talked to a few teachers. I think it's kind of okay in most of those cases, but this is one we hold on to, but we like to see the denominator rationalized. So let's take a look at it. Rationalized denominator. Again, teachable moment. The teachable moment is, what did the calculator do to get from 1 over the square root of 2 to the square root of 2 over 2? Hopefully students will realize that taking the square root of 2 and dividing by 2 is a much easier operation than it is to go the other way. To show them how easy that is, we just go back and say, you know what, let's just get rid of this and say, well, let's take the square root of 2. That decimal approximation, we can divide that by 2. Notice the answer. So I like the fact that it goes right back to an exact answer, which is what we want or what we expect from our students as they get into the upper grades. So it's a good time to start developing those ideas, those thoughts of how it is that you want to look at and see mathematics when you go into the upper grades. Again, if you press SD, it gives you the decimal approximation. You come right back. But since it does have the capability of simplifying square roots, you can start doing square root simplification, square root of 8, simplified radical form, decimal approximation, and right back. Square root of 27, 3 square roots of 3, and again, we can develop the idea of what is it the calculator is really doing. Why is it taking 27 and splitting it into a 3 and then a square root of 3? You can start combining ideas. Let's take the square root of 27, toggle out to get out from underneath the vinculum, outside the radical, plus the square root of 12. And why is that answer different from something like, let's say, this, the square root of 27 plus the square root of 8? Why do we have those two different from the problem I had earlier, which was the square root of 12? And again, I can toggle back and forth between the two problems and look at the two different solutions and start creating a discussion about what is it the calculator's doing, what is it not doing, what is it not allowing me to do, why does it not add 3 square root of 3 plus 2 square root of 2? Why is it only adding, or what did it do differently to get the square root of 5 square root of 3? Again, teachable moments that you can take with your students and really start to explore some different math and really start asking questions that our students have not been used to ask. Let me clear out my screen. One of the other ones that I really enjoy is the degrees, minutes, and seconds. It's also a calculation of time. So if you're teaching time, we can also do time calculations or degrees, minutes, and second calculations, which are exactly the same. If I take 2.75 hours, for example, as a decimal, I've got the degrees, minutes, seconds key right above the engineering. It's going to put in degrees. Now we have to press equals. It's going to give me 2 degrees 45 minutes. Or another way to think about this, if we're talking about time, this is 2 hours 45 minutes. 3/4 of an hour. So let's go with something in degrees, minutes, and seconds. Let's take something like 3 hours, 25 minutes, 45 seconds. I use this as a tool to verify, so students will not see this operation or this calculation the way we're doing it right away. This is something that you wait with. You still teach them how to convert. You still teach them to divide by 60 and do things like that, and then add up all your decimals. You press equals, you get the answer right back written in degrees, minutes, and seconds. S to D will convert you to a fraction, improper fraction in this case, because that's what we have our setup for. Press it again, and here it is my decimal, including the repeating 6. When you press it again, the repeating 6 has now been expanded to include those decimal places, but there is no repeating, and it rounds the last answer. If I press it again, it goes right back to the beginning. So you can ask, if it takes 360 hours, 25 minutes, 32 seconds to do something, what is that as a decimal? Equals brings you the answer. S to D. Oh, I've gotten to the limit. Let me clear all. 360 is a little too large. Let's go to 36. There we go. It does have a limit. You can't really get the fraction to be anything larger than, I believe the denominator has to be under 1,000. My 360 was over 1,000, but there you go. As a decimal, that's repeating as a non-repeating decimal. And that non-repeating decimal is an approximation, and then goes right back. All right, let's clear that out. Some of the other topics that I've come across, I used to teach 8th grade, and I'm thinking back to my days of teaching 8th grade and some of the difficulties I had as an 8th grade teacher. And one of them was teaching division. Division is always a tough subject to teach, especially when you start getting to the point where you have remainders. We do have a remainder division key. And I'll show you a couple of ways to do division here, where you can talk about the idea of a remainder and lead that conversation into a conversation about mixed numbers. So let's take something like 37. And we're exploring the idea of remainders, so we want to go alpha fraction, which says dividing by including a remainder, and we'll say 3. It's not going to go evenly, even though there's going to be a remainder left over. When I press execute, I get the answer of 12 with a remainder of 1. Another way I could do that is 37 as a fraction over 3. Now that time I typed in the 37 and then opened the template. The calculator recognizes that you want to make that the numerator. You're going to put in the division bar, the vinculum, and then you're going to put in the 3. There it is as a fraction. Here it is as a decimal. Now we can start connecting the idea of remainder. I did the exact same thing. What is that remainder? That remainder must be the 0.3. How do I get a remainder of 0.3 as a decimal when my remainder was 1? So we can start building that idea of what is the remainder doing, what does it look like, what does it become. Now if you really want to make the connection now, let's go one step further. I've got a template changer up here right above the source to decimal that shows a mixed number and an improper fraction. Again, that's a brownish key. I'll press Shift, S to D, and there we go. 12 1/3. So now I've gone from the idea of what does my remainder look like to what does it look like as a fraction, what does it look like as a decimal that's a repeating, non-repeating, and I go one step further, mixed number. Again, it's all within 2 screens of each other. Remainder, fraction, decimal repeating, decimal non-repeating, shift source, mixed number. So let's clear this out. This is all still in the home screen. There are some other templates I will show you a little later on, including some of the calculus ones that you've seen up here. But let's take it one step further. The other thing I dreaded teaching, that I had difficulty teaching students, was the idea of prime factorization. That is a very important concept, especially when it comes to factoring. When you get to the high school level, you have to know something about prime factorization. So let's take our year. Let's take 2012. I'm going to prime factorize this. So I'm going to press equals. Gives it right back to me. I see a button called fact, F-A-C-T. Again, it's a shift key. So if I press shift, fact, it now changes it to factorized form. So let's see if the year 2013 is factorable, or is that a prime year? Equals shift factorized. No, it actually is. I thought it was going to be a prime. Was the year 2011 prime? Oh, forgot to hit equals. Shift fact. 2011 is prime. Notice it's got parentheses around it that lets you know this is a prime factor. What I like doing with prime factorization now is extending that idea to develop the rules of exponents. So when you get to high school, you have to develop some exponent rules. I hate showing the exponent rules because, again, it just becomes a just do what I do and follow my rules, and they're the teacher's rules, and I don't really enjoy that. Students don't really remember that. So we've got another template. We've got the power template. So I'm going to take 2 raised to the 5th power. Again, it's a natural display, so in the natural display, the power will become elevated and becomes noticeable. Times 3 raised to the 2nd. I'm going to multiply that by a quantity, 2 raised to the 3rd, times 3 raised to the 5th. Oh, I didn't get out of my template. Let me get out of my template. Notice the natural display, though, did start increasing those the size of each one of these and continued with what it was doing. So it's a very powerful little machine here. Get out of the template there. Close it. That gives me just the answer. Now that's fine and good, but what I really want to know is what happens in the factorized form. Now that becomes an item of discussion there. What did the calculator do? What is the rule for multiplying powers? When you take a power times something else that has a power, I had 5, I take 3 more, I got 8, I had 3 to the 2nd, 3 to the 5th, and now I have 7. So this becomes a teachable moment. Instead of me giving them the rule, it becomes a time to discuss the rule and what is the rule. So let's take that same idea and we'll go and take this to the next rule, to the 5th, close my template, raise that to the 3rd. Again, let's factorize that, 2 to the 15th. How can I take this and get this answer? Again, it becomes a teachable moment, and I'm using the technology to help me teach the course, help me reinforce what I'm doing, help them develop mathematics on their own so it doesn't become just a series of rules that need to be remembered. Let me clear that. Let's go into something a little more into the high school realm. Some 8th grade, I know the Common Core is asking us to do a whole lot more with sine, cosine, and some trig ratios. So we've got trigonometry. Let's see what happens when we take the cosine of 30 degrees. Simplified radical form. Or I can work backwards. Arc cosine. What angle has a measure, or what's the size of the angle that has square root of 3 over 2 is its radian measure, or its measure? 30 degrees. You can do the same thing for tangent, sine. My science friends would not be happy if I did not show you some of the possibilities this calculator has in the realm of science. Conversion of units, for example. This calculator does allow us to convert units. Now, it does so many different conversions that you can't put it on a series of little screenshots. So what they've done is they have created a in the user's manual, this is the one time I do want to refer back to my handout here. In the user's manual, there is a table. This is clipped right from the user's manual. It says conversions, and you use different numbers. If you want to convert inches to centimeters, you type in 0, 1. It's 2-digit codes, all the way up to through 40. So that's where I'm referring to. That's where this is coming from. So I'll be referring to that. So if I wanted to take something like 45 feet and convert that to meters, what I do is type in 45. I want to find something that says convert. Above the number 8, it says convert. So I'm going to press Shift 8. This is where you need to know what each one of these is, or you have to have it as a reference. So as my reference, I'm looking at my reference here. It says 0.3 will convert from feet to meters. So that's the one I want. There it is again. Source to decimal. We'll change it. Source to decimal. We'll change it back. Shift source to decimal gives me a mixed number. Just to show you quickly some of the other advanced buttons on here, we can take cubed roots. It does not simplify cubed roots. You can take nth roots. It does not simplify nth roots. So I can't take the 5th root of 8, for example. It'll give me 2. But the 8th root of 16, for example, or the 5th root of 16, it would not. So it just gives me the decimal approximation. Just to show you real quick, let's go something like 16. So that one just defaults to a decimal. There's no way to change that back. So this does not use a computer algebra system. So this is completely test legal on every test, including the Regents exam in New York and things like that. All right, so let's go into algebra. The world of algebra. This is where students start asking you, well, why are we using letters to represent numbers? And again, depending on the level of student you have, it depends on how much algebra you want to allow them to have or allow them to use. I've got students, we've got what's called a block algebra, which is a double algebra for students who are having a little difficulty. This calculator makes life for my block algebra students a little more bearable, and it allows them to work in their own environment. And again, if you're differentiating in a class, this is a great tool for differentiation.
Ish, forgive me for interrupting, but I just wanted to
Sure.
double check something interesting. You know, you were talking about that very interesting conversion of units, and I just double checked on my handheld unit, and those number codes are inside the back cover for convenience.
Oh,
so that is
really?
I was hoping that was the case. I actually grabbed my unit to double check.
That's the advantage of having the
yeah, so I thought, wow.
Yeah, I don't have my unit with me. All I have is my virtual.
Exactly, but I thought before we were too far from that topic, we'd add that into the helpful hints. The back of the cover of the calculator has all 40 codes for unit conversion.
Oh, that is awesome. I did not realize that. I guess I got to check my cover.
Hey, while we're fielding questions, there was one other question specifically about the emulator. I knew the PC version was available. I was uncertain, and I did not want to give unclear information. Do you know about the Mac version of the emulator?
I am not aware of the Mac version of the emulator.
Right.
I'm not sure if that one is available or not.
Yeah, my thoughts were not yet. I just didn't know if you had any other information. We'll try to make that public knowledge as soon as we know.
Yeah.
Right, thank you, sir.
What's nice, I did not show about the emulator, though, is when you get the emulator software, it comes with not just this calculator. It comes with quite a few of the other ones. So that's also a very nice added bonus there. All right, so we're talking differentiating. Let's find the slope between 2 points, the point 3.7 and -2.4, and I want to find the slope. Now, most of your students, or most of my students, I can ask them to go ahead and type it in. say 3 minus the x-coordinate, which is -2. This calculator is very forgiving. It will allow me to use the minus key for a negative, but I'm going to use the correct key. Now, I want the students to know there is a difference. So 3 minus, using the shorter negative key, which is above the RCL for recall. Oh, you know what? I've got my x's and y's mixed up. I just made a mistake my students would make. Let's take the y's. 7 minus 4, toggle down. 3 minus, now this is where I want to use the negative, -2. There's my slope. Now, if I've got a student who's having difficulty remembering the formula, they don't remember what any of the numbers are or where you can plug in different values, the calculator does allow you to basically solve with some variables in there. So I'm going to put in some variables this time. I'm going to go with my fraction bar. I'm going to put in some variables this time. I'm going to use the variables a, b, c, and d. So I'll go alpha a minus alpha b. Those are my y coordinates. Toggle down. Alpha c minus alpha d. Those are my x coordinates. Changes in y versus changes in x equals, and I'm going to put this in the x variable. I'm going to use x as a variable. I know this, I wish I could use a different variable, but that's what I'm going to use for right now. Sometimes it will give you issues if you use y or if you use the z, so I'm going to use the x because I know that works. Now what I want to do is I want to be able to solve using different values of a, b, c, and d. So right above the calc key, you see a solve key. So if I press shift to solve, it's going to ask me a question. Well, what's the value of a? The value of a was my first y coordinate, or 7. It says currently your value of b is 0, and b is my second y coordinate, which is 4. C, now going to my x coordinates, 3. And D, I said, was -2. Again, I could use the minus key. I try to get the students to use the negative key because we are talking about a negative number. The calculator will allow the minus. It is very forgiving, but we want them to use the proper notation and proper numbers and letters and symbols. Solving for x, yes we are. Currently the value of x is 0, so press equals. And now you get your answer as a decimal, 0.6. Gives you part of what you typed in. Left minus right. What this means is this is what the calculator is doing. It's taking your left side, subtracting your right side, and giving you an answer. If this is an exact answer, or if both sides are exactly the same, that's going to give you a 0. If for whatever reason the left minus the right gives you something other than 0, you can resolve it and recalculate that value. But L minus R says that. All right. So again, I just toggle back, shift solve. If your students have another problem to type in, this is where I get my students who are having difficulty, or I'm differentiating because they can't remember the formula or they don't remember where things go. They get used to typing values in. Ooh, that was interesting. Oh, I know what I did. I typed in the same value for x's when I did this. That is the one issue. You can't divide by 0. But there you go. You can plug in values in algebra and use the solve. So for example, if you wanted to show students that the answer they do get in their equations when they're solving equations, you can actually type in an equation. Let's say I've got an equation like 3x plus 2 equals 7. And I want to ask them to solve that or have the calculator help them figure out whether or not the solution they got is true. Shift solve, solving for x because that is the only variable. And they can check their answer that way. Again, students won't know about that unless we show them, and I only show them that when they've gotten mastered the idea of solving, because me, like everybody else, I'm not going to just take an answer as a solution. I was talking earlier about the fact that the calculator does take the minus key in place of the negative. So if a student inadvertently types in 3 minus 8, the calculator is very forgiving and will accept it. I don't accept it, and I ask the student to make sure they change that, use the proper notation so that it looks different. So they do use the proper notation when the time is coming. All right, so that's just in the computational mode. We haven't even explored any of the other modes yet, so I'm going to go into my favorite mode of all, which is the verify mode. So I'm going to go into mode. Verify mode, toggle down, is on the second screen, number 2. The verify mode will say true false. This is a true false engine, which basically you can use at any level of student, any grade, you name it. You can do this with just about any age student you want. You can start out with things like, is the number 3 the same as the number 5? Is 3 equal to 5? Verify will just tell you true or false. Is that true or false? No, it's not true. Is 0.3 repeating? Alpha repeat the same as 33 over 100? No, it's not. Is the square root of 2 over 2 the same as, the same as 1 over the square root of 2? Oh, I got the wrong one there. Whoops. Let's do that again. Square root of 2 over 2. Get out of my template. Here you go. Square root of 2. The same as 1 divided by the square root of 2. What did I do? Oh, forgot my square root. And you can't have a repeating whole number there. Let me go after it and get rid of that. I haven't got rid of it. That's AC at all. Square root of 2 over 2 over equals 1 in the bottom, square root 2. Out equals true. It'll do inequalities as well. So if you take is 1 bigger than or less than negative 2. Now in order to do that, I need to find where it is, and I'm going to find this key for verify. So these buttons above the numbers 1 through 6 have these square brackets around them, which mean you have to be in that mode in order to use that button. So in order for me to use the verify menu, I have to be in verify. Shift 6. Here's my inequalities. I want to know, is 1 smaller than negative 2? False. You can do operations, you can do equations. Is 3 times 4 plus 2 greater than or equal to, let's go with greater than or equal to, 10. So the verify menu I really enjoy because it does let you do some very complicated things. Is 1/2 the same as the sine of 30 degrees? There are some limitations. It won't do some advanced calculus, for example. It won't do integrals and things like that, but it is a great tool for having students verify answers and verify relationships. So let's go into one of my favorite subjects, which is some statistics. This calculator does statistics in a very interesting way, but it's a very powerful way. So what I'm doing now is pressing mode. I want to go into statistics, which is option number 3. So I'm going to go into my statistics mode. Now I've got a choice here. I can do one variable statistics. That's what I'm going to do first. If I do 2 variable statistics, you can go into one of the other ones. But this is also going to do regressions. So this will do regressions that are linear, quadratic regressions, logarithmic, exponential, power. So you name it, it does quite a few of them. But we're just going to do some basic one variable stats. And for my one variable stats, I'm going to keep it simple. I'm just going to go with 1, 2, and 5. Just 3 data points. I want to calculate the mean of those 3 values. I'll press AC to get out of there. Again, remember I'm using my statistics button, which is above the number 1. So this is my statistics distribution button. Shift number 1. I could either find different types. I can go into find the sum, look at the data itself again, look at all the different variations or variances or means and different calculations there, and go into distributions and maximum and minimums. I go to number 4. X bar is being my mean, n being how many things are there, the standard deviation for the population, standard deviation for the sample. So I'm going to go with number 2. X bar, the mean of my data set 125. And there you have it. If you want to go back and find the standard deviation for the sample versus the standard deviation, again I got to go shift, go into number 4. It's all menu driven. The number 3. And then look at the difference. Let's do some linear regression. This calculator is amazing in that it can do linear regression, and it can do regressions. So I'm going to go into 3 and go back into stat mode. I'm going to do a linear regression, which is number 2. Here's my data table, X's and Y's. 1, 2, 3. And on the other side, I'm just doing 3. I know 3 is not a great data set, but for the sake of brevity, I'm just using a simple 3-point data set. I'm going to AC to get rid of that. Now what I want to do is I want to calculate the slope and the y-intercept along with the correlation coefficient. Shift, stat. Number 5 says regression. So let's see what number 5 gives us. You can find A, you can find B, you can find R, predict for X and predict for Y. So X hat and Y hat, you can predict Y given an X value, you can predict X given a Y value. So I'm in A plus BX mode, so A is going to be my intercept for that data set. I'm going to do that again, 5. I'm going to get the slope. Now I'm going to find the correlation coefficient. There you have it. You can do some predictions with the other values. I won't go into those because that's a little more of a high-end thing to do. Sticking with the world of statistics, I teach AP statistics, and if I ever come across a student who's having difficulty purchasing a calculator, it's a graphing calculator, I'm definitely going to recommend this one. Because now what I'm going to do is I'm going to go into distributions mode. I'm going to toggle down. Option number 3 says distributions. Now I'm in distribution mode. I've got normal PDF, normal CDF, inverse normal, binomial P, binomial C, and Poisson. Interesting that they went with those options. I would have thought they would put in a geometric. That would be nice to have a geometric one. Maybe I'll have to ask them for that one. Let's go into a normal calculation though. Let's do a normal cumulative density, normal CDF. The probability of seeing a value at or above, or even at or below a certain value. Let's go with from negative infinity, negative big number. Again, this is all template based. I don't need to know any of the syntax. The upper value, let's go with the upper value of 2.3. So I know the probability of seeing a value 2.3 or lower. When my standard deviation is, let's just go with a standard normal, standard deviation of 1, and a mean of 0. There's your p-value. Sort of a p-value in the opposite direction if you want to think about it that way, but that is your probability of seeing a value of 2.3 or lower when you've got a mean of 0 and a standard deviation of 1. So this is on a standard normal curve. You can type in your own mean and standard deviation. It does not have to be from the normal table. So I'm going to change the type. What I did there is press shift number 1. I'm going to go back into type number 2. Let's go with a lower end of negative infinity, upper end of 2.3 again. Let's change my standard deviation to 2 and my mean to something like 1.8. So a couple of slight different changes, we get a slightly different probability. Get rid of that. Random numbers. So if you do anything with random numbers in your class, I'm going to go back into my mode. I'm going to go back into number 1. So I'm back into my regular mode. Random numbers. I got random integers or random numbers. I like to do random integers. Alpha random number. This is an integer between 1 and 6. My comma key is right next to the right parenthesis there. Shift. Between 1 and 6. It's like rolling a die. First time I get a 2. And you can just press enter over and over again to get different values. Let's go into equation mode. We have a couple different modes to go into here. We won't get into all of them. We did not go into matrix mode. We're not going to do vector mode. Vector mode is on your handout, but we won't have time to get to that one. Let's go into equation mode quickly. Equation mode, which is number 5, is a good place to solve system of equations, 2 variables and 2 unknowns. That's what number 1 is. Number 2 is 3 variables with 3 unknowns, a quadratic or a cubic. Let's go with 2 variables or 2 unknowns, or you know what I like better? Let's go into a quadratic. Go into number 3. Let's go with a quadratic we know the solution to. 1, 2, and 1. It's a template, fills it right out. Press equals. There you have it. If I keep pressing equals, it's also going to tell me my minimum value for x and my minimum value for y. Let's try a different one. Let's try a system. We'll go with a non-singular matrix. -8 and 9. And there's your solution. Again, if you press S to D, you can get your decimal approximations. Inequalities. I was shocked when I saw this. Going back into mode. I'm going to go down into my inequalities. Inequalities, quadratic inequalities or cubic inequalities. I'm going to go with a quadratic inequality. I'm going to go with, let's go with greater than 0, number 1. Let's type in the one I have on the handout, which is 1, 2, and 3. So I want to find when is this quadratic, x squared plus 2x plus 3 greater than 0. All real numbers. It's always bigger than 0. I love that answer. Let's change the last one to a -3 and see what happens. There's your inequality. When x is less than -3 and when 1 is smaller than x. So it gives you the compound inequality. I was very impressed by that. That's amazing to have that power in a calculator like this. I'll show you vector mode quickly, and also one more thing for science people. I will show you scientific constants. The different constants for science are also built into the calculator. This one might also be on that note card that John was talking about inside the slide cover. So let's see if I can go into shift. So let me go into regular mode here first. So I went into mode, regular mode 1. If I press shift 7, which are my constants, these are different constants for science classes. Speed of light in a vacuum. There it is. Speed of light in a vacuum. There is 40 different constants built in.
And yes, you are correct. That is also on that cover.
Oh, that is cool. There are 40 different constants, and it says the values are based on CODATA 2010 recommended values. So this is up to date. This is a brand new calculator, so those values have been updated. Last mode I'll go into for today, just giving you a slight taste of what this calculator is capable of. Let's go into vectors. You can do vector addition, subtraction, you can do dot products, you can do dimensions, you can do absolute values for vectors, you name it. Again, it is all template based. I can choose a 3-dimensional or 2-dimensional vector. You type in your vector coordinates. You can take the absolute value, which I have not shown you yet, the absolute value key on the calculator. And of course I lost my absolute value key. And then I'm going to show you one very cool trick, which is how to generate the Fibonacci sequence, which I thought was, oh, there it is, absolute value. Shift absolute value. In my vector mode, I'm going to go in my vector menu, vector 3, absolute value of that. There you have it. So it'll calculate vector values for you. It also does vector dot products, the dimensions. So you name it, it does vectors in the different modes. It will do matrices. You can do a matrix. I'm just taking a look at matrices, 3x3 matrices. What does it do? It gives you the template for it. When I press shift and matrix, it gives you different options for matrices as well. One thing that I find really kind of neat about this calculator, besides all the other things, is it's got a previous answer key. This is something I was not able to do before. I press 1 equals, 1 equals. Now let's generate the Fibonacci sequence. I will press alpha, previous answer, plus the answer. And I keep pressing enter. There you have your Fibonacci sequence. Previous answer does is take the answer before the answer, hence the name previous answer, and I am generating the Fibonacci sequence with just 2 button pushes. This is amazing. There you have it. So that's just some of the things this calculator can do. I have scratched the surface. There is a large number of keys and things I did not even come close to talking about. That's a whole nother webinar. I didn't go into GCD, LCMs, you name it. It is all there. There's polar and rectangulars and all sorts of great things. Just to show you an integral on a scientific calculator. That's what it looks like. How about the integral of a sum, of a product, of a derivative? So there you have it. This is a scientific calculator. It is, in my opinion, the most advanced scientific calculator out there. This is a calculator for everybody. So that's all I've got for you today. John, you got anything else for us?
Appreciate your expertise very much. One other question that I was dabbling with, because you just mentioned the
Sure.
LCD and the GCM commands. And one question we had from one of our nice folks was, can you use those commands on more than two numbers, such as 3? Now, I have a partial answer. I could embed one command within the other. But I don't believe you can
Yeah.
do a simple input of just 3 numbers. Is that correct?
That is correct. You have to find the GCD or the LCM between two of them, and then take that answer and use it with the next one. So
Right.
yeah, or you could embed them like you said.
Yeah, you can do a single string, but yeah, I just want to make sure,
Right.
again, I'm giving accurate information. Very good.
No, you're right. It'll only do 2 at a time, but once you find the first 2, you can just take that answer with the third one. But yeah, that's just scratching the surface. This thing's unbelievable. It really is.
Well, very good. We thank
That's
you.
all I've got for you today.
We thank you very
Go
much,
ahead.
Ish, for your presentation. We thank those in the audience for joining us tonight. Do tell others that we have recorded this webinar, and it will be available on the Casio website. So anybody that was interested and may have missed that, or if anyone in the audience wants to do a little review again a little later, we promise this will be up as a recorded webinar, as are all the webinars that we do here from Casio Education. So once again, thanks so much for being with us tonight.
Sure. I believe they're also available on the Casio Education YouTube channel. I think that's actually getting some of our webinars up there as well. So check it out. It's lots of places.
All right. Have a good evening, all.
Take care.